Hi, welcome back. So we are in section 3, objects alike, in particular to discuss the outline polymorphism. Let's have a quick look about the point we're going to be covering in polymorphism. First of all, I'll just introduce you quickly to the main idea. And then after that, we're going to talk about the relation between the dunder-init method and how it can access the subclasses without even have to bother which one is the subclass. And finally, the duck typing principle when it comes to programming object-oriented. First of all, the concept of this fancy word polymorphism, actually, it's a different behaviors happen depends on which subclass is being used without having actually to explicitly know what the subclass actually is. Imagine if we have like a kind of program or a software that is running audio files. Simple principle is to give a file name, and then this file name will be processed somehow. He has access only to a play function, the outcome, of course, out of that. So you will be listening to this audio file. Now, the question is that what kind of audio file we have? Well, we have a few extensions, MP3, WAV, or something like that. These files actually, the way a play can process them, like decompressing or deserializing, etc. Each one of them has a different way, a different algorithm to do that. So obviously, this play wouldn't do the same procedure when you give the file name as an MP3 or if you give it as a WAV. End of the day, the user doesn't really care. What we want to see, we want to listen to the audio. And this is a great start example to explore to you exactly what polymorphism is meaning here. In this case, well, what I can do, I can create a class. This is the audio class. This is the main interface, so to speak. Then I could create a different class. Each one of them is operating, one for the MP3, maybe one another class for the WAV maybe, and something like that. And these classes simply will be inheriting whatever the audio class is in there. And here we can put like some play function. Now what happened when I have a file name, right? All what I have to do, I have to call on a function called play. Now this play function will absolutely be executed, depends on the file name. Actually, let's go and open our Visual Studio Code and try to implement this example. So here I am back to Visual Studio example. I'm just implementing what I was talking about. So here we have a class called audio file. All right, and this audio file in its initialization dunder-init, it's basically just take a file name. And I'm making here a very interesting check. I just wanted to check what is the extension of this file that you give it to me. So I'm taking this file name, I'm checking end with, it's also a built-in function given the object. And inside here, I am taking whatever the object you instantiated and I'm checking what is the extension of that. Now you should now ask me a question. What is this ext? And this is where the first principle of polymorphism can come in. It doesn't really care about which subclass have this ext. I want you to imagine this ext, in fact, exactly as if I am saying there are MP3, WAV, something like that. So I'm just checking if the file name, extension of file name given is within or one of those extensions. If it is not, raise an error. Otherwise, I want you to set this class variable called file name to this particular, of course, file name. Great. Now I went out of that and I created these two different classes, one to handle the algorithm for MP3, one to handle for wave kind of file name. And both of them are, of course, inheriting from the audio file. Now here is the ext. This is what I was talking about. Same I done for WAV, so I can have as many tabs as I want, and all of them are sharing this audio file. And let's instantiate it from the MP3 file. So we're gonna provide you with MP3 file. I can do the same object instantiating for another file. Let's also create completely something is not relevant, maybe XYZ. You see none of the extensions in there. Now for each one of them, let's play. Watch carefully what happened. First, playing my file with MP3, this guy here, and here as WAV. Everything's working, but look at the exceptions here thrown in the third line. He said here invalid file format, which is the exception error I said from the parent class. So that's why introducing this main idea we have seen just now, that the init really didn't know which subclass was operating. It was just a general ext. Lastly, but what is this duck typing principle? The general idea, it says, from the principle of polymorphism, it doesn't really care class or the object's been instantiated, what is the background of it. Let me exactly show you what I mean. Make a list, and inside here I'm going to create a few objects. Let me create an object of mp3 wav file. Now these are two objects from two different classes, and if I, for item in this list thing, I want to say the item dot play, he does not really care what is the structure, but what he cared about this method is it exists or not. Now, if I would have to run this example again, of course, encounter with an error, be surprised because this mp3 I'm calling on the wav, it's not going to work. So this must be actually wav. Let's run one more time. Playing as mp3 as wave, it doesn't matter. If I would have to add one more class, completely not related to the audio class, let's call it something else class. Just let me define a play as print I am different class. Now inside this particular list, one more object I'm going to be creating, I will call something else object, but it has this play thing exactly as expected. It's just working. Why? Because it's playing there. So you could see now this is polymorphism in action. This list represents different objects. Maybe two of them are relevant. The third one has no relevance at all in its structure, the way it works, but all of them have one thing in common. This method. It could be a variable name. It could be anything. This is exactly what polymorphism represent. Next, we'll be looking at the last outline of this section, and that is to discuss abstract base classes. I will see you then.